Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Aqilah binti Ahmed Saifuzzaman and my partner Azia Alina binti Kamzaiman. So we are going to present about elementary particles. The learning outcomes for this topic is we should be able to understand about 4 basic forces in nature, classifications of particles and quark. I'm going to start the presentation with the 4 basic forces. First, we have gravitational force. Gravitational force is the attraction between two objects that have mass or energy. It was the weakest among 4 basic forces. Second, we have electromagnetic forces. It exists between two charges, binds electrons to the positively charged nucleus to form an atom. Third, we have the strong force. It only acts on quarks. This force binds 3 quarks to form a nucleon and also acts on nucleons to form a nucleus. It was the strongest among 4 basic forces. And fourth, we have the weak force. It acts on leptons and quarks. It can cause the flavor of quark to change that can cause a neutron to transform into a proton in a beta-minus decay. Classifications of elementary particles. First, we have leptons. Definitions of leptons: a particle that does not experience the strong force. It only acts on the 3 basic forces, especially electromagnetic and the weak forces. Lepton has very small mass, so gravitational force is ignored. Lepton structure. A lepton is a really basic particle because it does not have any internal structure, meaning it is not divided into smaller particles. Lepton family, it has 3 generations. For the first generation, we have electron and electron neutrino. For the second generation, muon and muon neutrino. And for third generation, tau and tau neutrino. Second, we have hadrons. Definitions of hadrons: a particle which experience the strong force which act on 4 basic forces. We have 2 classifications of hadron. First, baryons, which contain proton and neutrons. Second, meson, which contain pions. For modern of hadrons, a hadron is composed of 2 or 3 particles that are known as quarks.
Next, I am Azia Alina and I am going to present about quarks. First of all, what is quarks? Quarks is a type of elementary particle and fundamental constituent of matter. They were similar to an electron and does not have an internal structure. They also contain charge and there are 6 quarks in different movement. Let me explain this further. A proton consists of 2 up quarks and 1 down quarks. 1 up quark is equal to positive 2/3 charge. Since we have 2 up quarks, then overall we have 4/3 charge. And since protons have 1 down quarks, we have negative 1/3 charge. By combining all these, 4/3 plus negative 1/3 charge, we will get 1 positive charge as the charge of proton. A neutron was found consists of 2 down quarks and 1 up quark. This results in overall charge of 0. Next, we move to the quarks family. Quarks have a strange name which are up, down, strange, charm, top and bottom. This is because they are named by component of their spin. Up and down is given name based on their spin. Strange is named because they have longer lifetime than they should have in a particle decays. The charm quark is because of fascination, the way they fascinate physicians, and up and bottom is because they were logical counterpart of up and down quark. Next, we move to beta-minus decay and neutrino. Beta-minus decay is an electron emission of an unstable nucleus. The emit energetic electron and antineutrino and neutron in nucleus become a proton. We can see this process through carbon-14 that were used in carbon dating. It is an unstable element that will result in decay by emitting beta minus particle then transforming itself into nitrogen. The equation shown byproduct consists of nitrogen 14, antineutrino, and electron. Why is it antineutrino and not neutrino? This is because in decay, the lepton number is conserved, and to balance, antilepton must also be formed, which is, in this case, is antineutrino. The opposite of beta minus is beta plus decay. In this process, a neutrino is produced. These are some of properties of neutrino. Neutrino is not charged, so electric force does not react on it. Since its mass is almost zero, gravitational force also does not react on it. The strong force also does not act on it. It looks like the only force that acts on it is the weak force. Scientists find it difficult to detect neutrinos even though a lot of them are available. Neutrinos are found in cosmic rays and in the core of a nuclear reactor. That is all from us. May you get beneficial knowledge from this video and thank you for watching.